let's dig into the issue, the challenge of latency, why it sucks, and how to fix it. Here's our moderator, Jason Thibeault. Take it away, Jason. There you go. Now you're unmuted.
All right. No, I'm not muted. No, I'm just kidding. Anyway, thanks a lot, Eric. I appreciate that. And thanks to Limelight, and thanks to Haivision. Obviously, this is a first time for everybody with virtual events, and I think a lot of them are turning out great. So thanks to Stream Media for pulling this together, and all of our panelists for joining on this topic. A little bit about myself. I'm Jason Thibeault, the Executive Director of the Streaming Video Alliance. If you don't know what we are, we're a technical association. We're global. We try to solve critical technical challenges in the streaming video space, and we do that through member companies that join our organization and collaborate together to produce best practices, specifications, guidelines and things like that to, again, address some of those critical challenges. You can find more about us on the web at streamingvideoalliance.org. Now, with that said, to just parrot a little bit about Eric provided you in terms of housekeeping, if you have questions, submit them. We will stop periodically during our discussion to see if there are any audience questions, and we'll get those addressed by our panelists. All right, for now, what we're going to do is we're going to go through some brief introductions. So we'll just basically go by company. Unfortunately, we don't have one of our panelists today, Rob Dillon, with Sinclair Broadcasting. He unfortunately had a conflict. So today we still have three really experienced guys on, to talk about why latency sucks or doesn't suck, or what we can do to make it not suck. And so what we'll do is we'll just go through some introductions. We'll start with Rob from CenturyLink.
Hi, Rob Roskin from CenturyLink. I manage the team of solutions architects at CenturyLink for the CDN. And I've been involved with live streaming for at least the last 20 years, let's call it, and specifically low latency over the last 5 or 6 years.
Awesome, thanks, Rob. 20 years is, paltry.
Yeah, exactly.
Casey from Gigcaster.
Hi, I'm Casey Charvet, the Managing Director and founder of Gigcasters. At Gigcasters, we provide live streaming services, engineering, turnkey products for video transport and acquisition, as well as bespoke software development and services for professional content creators and commercial content distributors. Been doing Gigcasters for 6 years now, and overall been doing live streaming for about 20 years as well. So definitely seen lots of issues where latency has been a pain, and trying to fight that demon best we can.
Great, awesome. And then last but definitely not least, we have Marc from Haivision.
Yeah, hi. Marc Cymontkowski. I'm VP of Engineering for the cloud side of our business at Haivision. Haivision is dealing with low latency video, whether it's encoders, decoders, streaming appliances, or software solutions. We developed the now open source since for 3 years now SRT protocol, which is designed for low latency streaming. So one of the topics I keep blabbering about.
Awesome, fantastic. All right, so let's jump into some questions. Let's start out with something that's a little kind of like higher level so that we can set the stage. Maybe Marc, maybe you can start us off with an answer to this, and then, we can all jump in to discuss. But, when it comes to streaming video, I think we need to sort of establish a baseline, basically answering the question, what is latency, right? So, and what isn't latency, right? Should, the industry really be focusing on, glass to glass, or is it more cache to glass? Can you give us your thoughts on that?
Yeah, I think that really depends. In our use cases, many times that is really glass to glass, because we are managing end-to-end workflows from encoders through streaming servers to decoders. And the end-to-end latency is what many of the customers actually care about, because they want to know when the signal that is originating in area A is visible in area B. So you know what the expectation is, like how late am I in the game to make a decision? Because most of the time that somebody uses our equipment, they want to make decisions fast. But I guess that's a little bit different when you talk about delivery at scale. So that's probably what somebody of the Rob or Casey need to jump in to help me out.
Yeah, I would say we usually go glass to glass because the rights holder wants to know, after the football is caught or after the dress goes across the red carpet, when will people see it? That's the general question that seems to make monetary changes. Obviously everybody wants that to be as close as possible, and we'll surely get into the ways to do that.
Definitely. Casey, thoughts?
Yeah, in a lot of cases, we are focusing on low latency when we're doing remote production. And in this case, we actually are sort of measuring latency between, I guess you could call it glass to glass, but it's not distribution at scale. It's the latency between content acquisition and then when somebody in a remote MCR, remote ME situation can take action on it. So, in that case, I would call it glass to glass. It's just where you're positioning the glass. So we're kind of talking about signal acquisition at an event, and then a technical director operating on that in a control facility. But in interactive situations, it matters too. So,
and it seems to be sort of like right now is a little weird, right? I mean, I guess when we talked about glass to glass before, you would have like a camera at an event, and that camera was hooked to an editing truck, which was hooked to a downlink facility, and so that just flowed that way. But now, we haven't been doing anything at events. Like those cameras are now in somebody's house in this sort of like mock production studio, and it seems to sort of the definition of how to measure latency, or sort of what's all encompassed in understanding latency, seems to have been shifting recently. So I mean, it's interesting that you guys all are adding to this definition, but there's no like, this is latency. I think that's very interesting. In terms of that though, right? So, once you've acquired the content, right, and now you get into this concept of delivery, obviously caching plays a huge part of that, right? So that can significantly reduce round trip time, which is great. But, what happens when there's a cache miss, right? So obviously you've got to go back to origin. How do you improve caching in this sort of latency workflow? And how do you make all of that better? I mean, or maybe it doesn't matter, right? Maybe that really is not a contributor to latency in terms of getting content from, after it's been acquired to the end user who's requesting it. But let's talk about that a little bit. What role does caching play? Is it important? How do you make it better? All of the above. Actually, let's start with Rob.
Sure. So there's kind of 2 points there. How do you make caching better? You write better software, you have better machines and better algorithms that move things around appropriately. So when things get hot, they're there and they're ready to go. The bigger one is that cache miss. And I think that leads us into some other technologies that are more UDP based, be it on the acquisition side with RIST and Zixi, or if you see it on the delivery side with H3 coming out with quick support and some of the other proprietary solutions that we see out there. When you have a cache miss, you need to get it there as fast as possible. It basically becomes a stock quote or a shopping cart kind of scenario again. It's almost an e-com thing where you need to get that there as fast as possible. And that's when we get back into TCP optimizations and preloading and all those things.
I mean, thoughts, guys, on caching? I mean, let's look like, what's the role of hardware there, right? So you've got, you're acquiring a signal, you're getting it to your end users. You've got caches so that you can improve the round trip time, right? So the user doesn't have to go all the way back to the source, to the origin to get the content, they can go to the cache. Does hardware play a role in there? Like are like better boxes, better balanced on the servers? Like how does that all fit in? Marc, do you have any thoughts on that, or Casey?
So I think a lot of the latency discussion in the last couple of years has been shaped by the dominant technology that we use to distribute streaming content, and that's HLS. And just the sort of very nature of that protocol means that there is, the video's chunked, and you're going to have a certain number of chunks, and that adds a huge bit of latency to the whole process. I think, you mentioned QUIC and all of these UDP protocols that are coming out. And so we might be reshaping the way we deliver at scale, and we might be getting towards a post HLS or post, I don't know what's called, post chunked media world. And if we get there, I think a lot of these talks about caching are going to get reshaped. Hardware definitely does play a huge role in that. You know, we can get ridiculous throughput through a box now. We can get, you know, it's pretty easy to order up 40 gigabit line cards on stuff and memory and SSDs and all that. So these servers that we use for caching are immensely powerful. I guess to turn that back around is, if we move to a post-chunked media world, is that going to matter?
That's a great question. Marc, thoughts?
Well, yeah, if we can handle the scalability for those large-scale events in a real-life scenario, that's a different challenge than rebalancing caches, right? I think a lot of acceleration on the edge could happen there, like optimized hardware for ingest portal and egress. So you can actually optimize certain protocols right at the edge.
Well, and that's a good point, right? It's not a one size fits all, right? So that, I mean, one would think that your profile for your caching or your caching strategy has to be reflective of the kind of traffic and content you're pushing through it. So to Casey's point, if we move away from segmented video delivery, or if it's something else, then obviously that would impact sort of how those content deliverers, optimize or tune those servers to improve the caching, or maybe caching's not even needed. I don't know. Crazy thought. That brings up, kind of the talk about hardware. It brings up other questions, right? So if we assume that again, latency is, let's say, glass to glass, we know that there are lots of components on the way from when content is acquired to when it's consumed by the viewer. So, there are things in the middle there, right? There's encoding, right? There's a box or a virtualized container, something that is turning the video from, one bitrate to another, one format, one package to another. And there's things like DRM, there's things like closed captioning, there's things, there's all sorts of things in the middle. Let's talk about encoding a little bit. I know that there's been a big push, amongst a lot of the encoding vendors out there to do context-aware encoding, right? So not applying one profile to every frame of the video, but applying multiple profiles to the frames depending upon what's happening in the frame. So if you've got a talking head, that's different than somebody running down a field kicking a soccer ball. What are some choices that can be made during encoding to improve latency, right? If that encoder, that thing, is responsible for some delay during getting the video from the glass to the glass, what are some best practices around like chunk size? What are some best practices around profile variables? And maybe Casey, maybe you can give us some thoughts on that. I mean, obviously you guys are doing the whole thing, so. Yeah,
well, we've written an encoder, so yeah, we've definitely been in the guts of this. Before I jump to that, there was Eric notified us that there was a question about what is HLS. So I'll just say that HLS is a standard. I think it's hypertext live streaming. Is that right? Did I do that acronym right?
HTTP live streaming.
Yeah. So it's a standard that Apple developed and kind of became the de facto standard for live streaming content, or not even live, just streaming content delivery at scale. I think the take-home relevant for this panel is that the media is cut up into small chunks or segmented, and these are usually, I think the initial spec was 10 seconds, and generally a playlist will contain 6 of these or more, but I think 6 for live is kind of a standard. And then a client usually won't start playing back the video until it's received 3 of them. So this means that in the most default setting, you're 30 seconds behind live. And so when HLS kind of became very popular, everybody's like, oh, the latency is so bad on it. And those were all just design considerations. Okay, so encoders, right. Let's say your camera adds a frame of latency or 2 frames of latency. Your video switcher adds 2 frames of latency. On our encoders, the default, we use some techniques for rate control, and it looks ahead 4 frames. So it has a 4-frame buffer in the encoder itself. The acquisition card taking the SDI signal has a buffer. So before we've even begun processing video frames, we're already, 6 frames in, and that's about 1/4 of a second, at 30 frames a second. So, it's very easy to find yourself at a second of latency or half a second of latency before bytes have even left your origination site. Some of the things that we do to combat that is we can say, okay, well, we don't care that much about rate control, so we're just going to throw that out the window. We're going to turn that 4-frame look-ahead buffer off if we want low latency. We don't care that much about quality per byte efficiency, and so we're willing to spend a few more bytes to have lower latency, and so we might have shorter keyframe intervals, so we're sending out more iframes. If you want the lowest latency possible, you just put something into a near real-time encoder and MPEG TF iframe only, and throw it somewhere, and you have 35 milliseconds of latency, and it's great. But that doesn't work when we're trying to deliver over constrained bandwidth or deliver at scale. So, but I think there's definitely ways to tune your encode profile on the origination side to get lower latency, and if you start there and work all the way through your production pipeline, your net latency at the end is low. If you start with a lot of latency at the beginning, you're going to be fighting that the whole time.
Any other thoughts, Marc? Any thoughts on that?
I think it's important to differentiate the 2 sides of the story, the ingest side and the delivery side. On the ingest, you actually often have low latency protocols. Because as Casey mentioned, if you have an MPEG TS encoder and it's a hardware appliance like our encoders, for example, you can achieve very low latency. You can wrap that in a transport stream. You can send that either over local network, and then you don't have any issues. But as soon as you go over the public internet to reach the cloud, whether for transcoding and repackaging and then delivering the video, or for direct distribution end-to-end, that ingest is a complicated part, because often you don't have the quality of the network that you would wish you have on-prem. So getting the content into the cloud is the first challenge. And in many cases in the past, RTMP has been used to do this, which is a TCP-based protocol that comes with a lot of limitations because of the congestion control and some head-of-line blocking issues that cannot give you the full throughput. And then the emerge of UDP-based protocols, where SRT is one of them. There's others out there. And they utilize the available bandwidth better, but you have to recover for packet loss that happens on the way. But then when you hit the cloud and you want to deliver to many people, then a stream like an MPEG TS is not very scalable, because you need to deliver the whole data live linear to every single person. So that's where the boom of HLS started, because suddenly you repackage the data, and with the TS it's pretty easy. You just chunk the TS up, and then you can make an HLS stream out of it. And the moment you have chunked it up and put the data into segments, you can scale better, because you can use a caching mechanism to distribute basically files across servers and then deliver. And that's where on the delivery side then the latency is introduced.
Anybody extra thoughts on that? I mean, that's, it's there are lots of considerations to be made around encoding and, around delivery, right? So latency, and it's funny because when we talk about how do you solve latency? Latency sucks. How do you fix it? Well, okay, well, I've got a list of 157 things that you could do.
Right.
to do them in different combinations and optimizations depending upon the kind of content you're delivering. And then you actually have to look at the player, because obviously there are trade-offs for chunk size or segment size related to the buffer. And then you don't want people to be disconnected from the live, but then you don't want too much bit rate switching. So it's just, there's just so much to talk about. We actually had a couple of questions come in, so I kind of want to do a little break here, because the next question I want to ask you guys is really around sort of some of these new low latency packages like LLHLS. But let's ask some of these questions first. So the first question we had was, what are some basic tools or services that can be used for low latency with live streaming? And yeah, that's the first question. So basically, you know, kind of like what we just said, what are some practical things that somebody could use to improve latency? Are there something you can, you can include in your workflow that will help latency? Or, are there some tools that you can use, from a video production, video delivery, video packaging standpoint? Anybody have anything off the top of their head they could throw out there, somebody could use?
I think the first question is how many people are to watch the stream? Are we talking about 10,000 or million? That's where you have to separate. If you say 10 or potentially 1,000, it could be a live linear delivery and it works. And then low latency protocol like SRT is giving you all you need. But then if you want to take it to the millions, I mean, then the considerations become a lot more complicated, because then you run into all the scaling issues that we just discussed, and which protocol do you use and how do you optimize the whole end-to-end delivery chain.
Well, and that's a great recommendation or tool right there, right? It's almost like a planning tool, right? You need to plan first, what are the parameters of your live stream, and that will affect the decisions you make in terms of what technologies to use to achieve really great viewer quality under those parameters. I mean, that's fair. Casey, any thoughts, any tools that you guys might use, that you could throw out there?
Yeah. So definitely we also want to consider the viewer quality of experience as well, because if you go too aggressive on latency and you start causing an interrupted playback experience for the end user, it could be pretty detrimental. If, let's say, we do a lot of concerts and other events of that nature, and turns out people don't want a break during a live concert and have buffer underruns and have the music interrupted. Whereas if you're doing a video chat and there's an occasional dropout, it's fine as long as you don't have these, kind of 2 or 3 second pauses. That's a much more annoying part of the experience. So, in some cases, sometimes when somebody asks me for a low latency solution for their event, I'll say, well, how low do you want the latency to be? And they'll say, well, as low as possible. I said, okay, is that really your consideration, or is that just the easiest answer? And then, yeah, to Mark's point, scale is very important. It's not tough to do a WebRTC stream or use some other kind of unicast type solutions. WebRTC has been extremely valuable for a lot of remote production work that we've been doing. And there's a number of solutions out there. I mean, you can kind of set up 2 web browsers to do a WebRTC peer-to-peer type communication. And I know that a lot of the media server software offerings out there support WebRTC as well. So things like Wowza Media Server. And I think I'm not sure about their cloud offering, but I know that their streaming engine supports things like that. So, those kind of selections on the distribution side can help cut latency a lot.
No, it's great.
And provide for an interactive experience.
Yeah, you touched, Casey, on the quality of the experience versus the low latency. I mean, to the question about practical things you can do single bitrate, do bad quality, do baseline encoding, do as little as you can everywhere to just get the stream out, get rid of all the buffers that you have in all the devices. Most of the software and hardware have a low latency flag right now that'll do other tuning and, in the code. So that's kind of the practical stuff, all 157 things that you said, Jace. But unfortunately, there's no toolkit yet that kind of does all of that and says, oh, you're using this encoder and this, use all these settings. So it's still a little more difficult than that. but there are ways to do it. They all affect the quality of the playback. You're not going to get it on a 55-inch, massive, 150-inch massive TV. If you're going to try to do it with 1 second of latency, you're not going to get the quality that you would need in today's world, realistically, on the public internet to do that effectively without a proprietary technology. Yeah,
no, I mean, and I think, I think partly too is a lot of people don't really understand what the buffer, like on the player, is for. Right, and it's, it takes in a certain amount of data. So in the event that a network disconnection happens, the person can keep watching what's in the buffer in the hopes that the player reconnects and starts to fill the buffer back up. But if you go ultra low latency, where you basically you don't put anything in the buffer because you're delivering everything in real time, and then if the connection severs, well, then the person's just cut off from the video completely. So there are just so many considerations to be made. It's a very interesting question. It might actually prompt, at some point somebody like the Streaming Video Alliance to come up with, something around that. We're actually working on a doc for best practices to reduce live stream latency. And it's a lot of this stuff. And then they're going to put it into a POC and test it all, and then almost redo the paper with the results of like, hey, we tried that tuning and it didn't work. So we tuned it this way instead. So anyway, I think there are things coming out that will help, but right now, like he said, there's really no sort of toolkit. It's like, here, use this, it will all work. One last question, because this will actually lead into the next one. It says, what viable alternatives to chunked delivery were you referencing? And I think it was Casey who was talking about that. And the question is like, is that some sort of SVC?
Yeah, so I mean, there's a couple of different things that we're looking at. One is sort of an internal project, but I think that spiritually it's related to all of these other technologies. And that's the idea that we have, HLS was, I don't know, 10 or 15 years ago when it came out now. Let's say at least 10. And the network landscape looked pretty different, and Apple was concerned with delivering video to phones over a 3G network. And, the amount of bandwidth that we're going to have with I don't want to jump too far ahead because I know that's on the list, but, I think our ability to reliably deliver packets now has gotten to the point where, we're going to begin to see things like Quick and SRT and WebRTC and other mechanisms of pushing a constant byte stream begin to show up at scale. I predict that those are going to show up, and those are going to eventually replace HLS and Dash and other sort of segmented formats. I don't have one right now that I can say, oh yeah, this is the way to do it. I don't think that exists yet, but I think it will soon.
No, I mean, and that's interesting. So that actually leads us right into the next question, which is around some of these new, formats that are coming out that are low latency specific, right? So we had HLS, we had Dash, then came CMAF. So we had these different packages, these different formats. And then as sort of the question or the need for low latency really got heated, these specs kind of went back to the drawing board to say like, okay, let's optimize for live delivery, low latency streaming. So now we have LLHLS for low latency HLS. We have low latency Dash. We have low latency CMAF. What do these, are these packages that people should really, or formats people should really be utilizing? Are they baked, proven out? Have you guys seen anything in terms of testing with them that really says, whoa, this solves the low latency problem at scale? Oh my gosh, everyone should use this for live streaming. Let's start off with Marc. Have you guys seen anything around this kind of stuff?
Yeah, I mean, we do play with low latency CMAF and Dash, because one of the trials we did recently is to actually package that over an SRT connection for ingest. So you can distribute Dash low latency coming from the encoder directly into the cloud. You don't need to transcode repackage, and then the delivery is kind of like a classical HTTP delivery. And in the demo that we did, which was from an encoder to a CDN, through the CDN to player and playback, we achieved 1.5 seconds end-to-end latency. So I think there is potential in that area.
Yeah. Casey, Rob, what have you guys seen with these sort of newer formats, these low latency focused formats?
I'm watching Quick carefully. I think something like
Google Quick or IETF Quick?
Right, exactly. And this kind of underscores the issues that, you know, people kind of understand an approach. There's not any, I wouldn't say that there's a standard and there's not anything that works. You know, academically, I think that approach is going to probably prove out. But in terms of right now, if a client comes to me and says, hey, I've got a job and it's next week and I need to deliver to 10,000 people, I'm not going to recommend anything other than something tried and true like HLS. If, you know, and we can cut segments down to, you know, 2 seconds if they want low latency like that. But, you know, I think as these low latency revisions come out to the existing protocols, they keep kind of approaching sending a constant byte stream, because the Apple LHLS, I mean, they're basically like, okay, well, here's a 200 millisecond segment, and here's another 200 millisecond segment. It's like, well, at a certain point, you're just delivering, you know, how many milliseconds of video are in a 1500 byte packet, you know, and I think we're getting closer and closer back to unicast streaming. That's, you know, after we sacrificed RTMP and all of that, I think we're just going to kind of end up back there.
Yeah, I mean, from the delivery side, we haven't been seeing huge uptakes of the low latency HLS dash, well, I don't think low latency HLS is ready yet, frankly, but even the dash or CMAF ones. CMAF inherently is a little better at low latency for reasons we won't get into now, but it seems that the people that want to do, if you want to beat TV handedly, if you like, so TV is about a 10-second latency, give or take. And if you really want to beat that, we're still in proprietary protocols in the millions of users. Again, if you have 10,000 users, as we've been saying, there's ways to do this. If you're Disney Plus, you're back to HTTP-based protocols. And I think the thing that we really need to get rid of, regardless of whether we transfer files or how we move this data in a bitstream or files, is that TCP handshake of, yes, I received those video files. It's already too late to tell me if you haven't most of the time. So if you're not getting them, just wait till you get the next one and drop it on the floor until you're ready to go, which is more of the UDP style of technologies. And I think in order to reach these latencies at these scales, we can't have the ACK of the TCP anymore.
I also think, I'm sorry. No. I also think that it's interesting. We're seeing more and more peer-to-peer protocols, and most of them are basically scaling the HTTP-based delivery by redistributing segments from one player to the other. But I do think there's a future for low latency peer-to-peer, where actually live streams are distributed between the peers. And that's something that we are working on our side as part of our SRT initiative. We have a plan to come up actually with a low latency peer-to-peer mechanism to bring scalable low latency to the end users.
No, and that's, you know, and it's interesting that you mentioned peer-to-peer, right? So I actually want to come back to Rob here for this next question, which is around protocols and around delivery protocols. And obviously, Marc, we're gonna talk about SRT for a little bit. So, you know, please jump in. And then Casey, you know, you guys are probably all, you know, you were talking about Wowza earlier. So, you know, there's a lot of discussion to be had around, you know, sort of protocol support and in terms of what is the best protocol for the kind of traffic, right? So, like video delivered as part of online gambling, like probably the best protocol for that is a real-time streaming protocol, like, you know, RTSP for lack of a better one, but something like WebRTC versus something that maybe doesn't need that kind of latency. So, you know, it might be safe to even segment latency. Like there's, you know, live streaming latency, which is maybe like, you know, low latency, which is maybe like 5 to 7 seconds. Then there's, you know, lower latency, which is like, 1 to 5 seconds, and there's ultra low latency, which is like under a second. So it's, I think there's some place to define what those things are, but obviously the protocols and the protocol choice for delivery has a big impact on the user experience in terms of the latency. So Rob, can you talk a little bit about sort of like some of these competing protocols that are out there?
Yeah, sure.
There's obviously Quick, there's SRT, there's WebRTC. How do these help reduce latency? And what are you guys seeing in terms of usage? What are you guys using, as a CDN?
Well, we use whatever the customers want us to use ultimately, but
yeah, that was a stupid question, sorry.
No, but what we try to do is not get too proprietary. When we really think somebody has a winning great idea, we will take care of it. For example, we bought StreamRoot last year, and they use the data channel of WebRTC to send regular HLS. So it's not WebRTC, the protocol really, it's just using a channel in that because it has worldwide browser support to be able to send your regular HLS in a peer-to-peer fashion. Everybody can watch the movie at the highest bit rate. Everything is great. When it comes to some of the, as you had said, the 1 to 2 seconds ultra low latency, there's very specific use cases for that often don't involve a CDN. Usually when guys are trying to do that today at scale, they come and buy IP from CenturyLink. They buy a 100 gig port and they do it all themselves. Guys, Twitch would be an example like that. If you can shave off a 1/10 of a second of latency, they'll take it. And whatever you can do to get them that, is interesting to a guy that's doing gaming. Every fraction of a second can matter. Most of our customers tell us to beat TV. And that's where we found our sweet spot to be. And that's where things like Quick, on the ingest side, obviously SRT and things like that will help reduce these multi-second latencies down so we can allow for variations in the network or in the delivery or the ISP, whatever it is. And so that's where we've really been focusing our protocol support on H2, H3, all of those kind of things.
Marc, come on, Marc, SRT, talk it up.
Yeah, I mean, SRT was developed because of the low latency problem. When Haivision traditionally had their encoder decoder solution end-to-end very low latency, it was typically protected networks, satellite links, MPLS, like all expensive solutions. But at some point we figured we need to carry it across the public internet to have a reasonable price solution, to be able to connect different facilities across the public internet. So we designed a protocol that is basically a UDP protocol, but does make sure that your packets that are lost on the way are retransmit. And the stream is encrypted with AES encryption. But something that people underestimate is it also recovers the timing of the signal. Because if you send a very low latency signal, real-time signal, a transport stream from an encoder to a decoder on a local network, basically the signal doesn't change. If you have a VBR behavior of that, of your coming out of your encoder, for example, it has a certain shape on the network. You need exactly that signal to go into the decoder because it will decode one frame after another exactly the same time it was encoded. If you send that over the public internet, it changes your stream because of the jitter and the delay, and all the problems of the different paths you have over the public internet. And then on the receiver side, you need to recreate the signal behavior in order to feed it into a decoder for low latency decoding. And that's why we put this mechanism into the protocol itself. So SRT itself recovers this timing for you. And that's how we achieve the end-to-end super low latency. And we're talking here about 2.5 times the RTT typically. So if you have 100 millisecond RTT, 300 milliseconds end-to-end glass-to-glass latency.
Yeah, I mean, that's great, right? I mean, and that's why I wanted you to talk about that a little bit. There's been a huge, push for SRT adoption and usage, and people I think are still, they're still experimenting with it. Obviously trying to figure out where does that fit, in my use cases for delivery. Somebody had mentioned RIST as well, right? Because there's obviously, another protocol there, to talk about, and we could probably do a whole panel just on talking about protocols. But Casey, can you add anything to that? I mean, what are you guys seeing in terms of the benefits of these different protocols and in terms of your guys' delivery and your offering?
Yeah, so we do a lot of work with Zixi, and so in our encoders we support the Zixi protocol, the SRT protocol. We haven't added in support for RIST yet, but I know there is now a free library implementation of RIST, so we're going to be looking at that pretty soon. The one thing I do want to point out that's interesting about a lot of these solutions to make UDP reliable, we have tunable latency in these protocols, right? So we can specify whether we're using Zixi or whether we're using SRT, and I assume it'll be the same with RIST. We can say, okay, how much latency do we want to allow for in this signal path? And so I can set the latency at 500 milliseconds or 1,000 milliseconds or even 8 milliseconds or 8,000 milliseconds if I want. And all of these are dependent on the quality and characteristics of the unmanaged pipe between my A and Z points, right? So I have a really clean link between the origination source and where it needs to end up. I can set that latency really low as as Marc mentioned, typically 2.5 times round trip. If you think you're going to have more packet loss, then you can add more latency back in to help compensate for that. And there's other techniques as well to compensate for the packet loss, like forward error correction as well. And so these are all kind of things that help us keep it low latency and move away from the TCP ACK problem that Rob mentioned. So I think that these protocols are definitely the right solution. And they're all kind of converging on the same set of solutions. And then it kind of becomes about features and software tooling and the media servers around that support that. But yeah, we use, hardly ever use an RTMP link from one of our encoders to anywhere these days. We will definitely throw it onto one of these reliable UDP protocols and use that instead. And overall, it just works a lot better with the benefit of typically being lower latency.
No, it makes a lot of sense. I mean, and that's great. I mean, that's really cool to hear from all three of you about sort of your experiences, and knowledge about some of these protocols. Because, if you're delivering live streams right now, you've got to be asking yourself, like, which one do I use? Like, which one's best? And I think it goes back to that whole sort of, is there a toolkit? And part of that toolkit is a planning or strategy. And you've got to have a strategy on what works best for my use cases. But, and we're going to jump to questions here in just a second. Maybe we can divert for a little bit of time to talk about multicast AVR. Obviously, live streaming over the internet is unicast, and that sucks because that's the same stream to each and every individual session that's connected to, whatever that delivery agent is. Multicast could potentially solve that problem. Maybe Rob, you can talk a little bit about it because you're coming from a carrier perspective and you guys have a managed network in addition to delivering things out over the open internet. What are you guys seeing about multicast AVR? Any tests? Anything?
Yeah, I mean, it's good. I don't mean that negatively. Like we've done our tests. It does its thing. We've been able to use satellite to the home and then break it out in the home back to unicast and all those kind of things. You end up with a gateway home box that can then do other things as well, even down to manifest manipulation if you want to add back in ads and all that kind of stuff. So we've had no problem with it. We haven't had 100 different customers coming, knocking down our door and saying, if this isn't on your roadmap to get done, then you're out. But everything that we've thrown at it has been good.
No, that's cool. Any thoughts, Marc or Casey, have you any experience with multicast, any thoughts on multicast? I mean, it really does seem like this might be a way to solve a lot of the latency issues, but there doesn't seem to be a huge deployment right now.
But I'm coming from a multicast background, but again, on local area networks, not on the public internet. So that's not my area of expertise, really. On a local network, I mean, obviously it's awesome, right? The best scalability you can get if you have an enterprise network and you need to deliver to 5,000 people in that network, and the network is probably configured to support your multicast, then that's the best method of delivery.
Yeah, Casey, any thoughts?
Yeah, I mean, we do some work with multicast as well for one of our clients, and I think there's a lot of interest in that. And I know that we actually, I think it's one of the topics that we have going in the SBA, right? Yeah. So, yes, I think that's going to be the thing that maybe gets multicast to happen on carrier networks. It's we definitely have it with our client. We have it in production at a reasonable scale. I don't think I can give a ton of details about it, but it's a solution that works. There are definitely complications about managing, if you have sort of the customer premise equipment joining the multicast domains and leaving it and authorization. There's a lot of back office considerations besides just the actual network pipe itself. But I think that those technologies are, we're writing them and they're maturing, and we can achieve unbelievable efficiency through multicasting.
Yeah, we did do a tech brief on multicast, and I know that our networking and transport group is going to sort of readdress it. But the thought that we basically wrote the paper that said, like, this technology is awesome, but it's a chicken and egg issue, right? So the carriers don't want to invest in multicast because there's no player device ecosystem, and the device ecosystem doesn't want to implement multicast support in their devices because none of the carriers are delivering multicast. So it's just like, who's going to move first? So I'm bullish on multicast. I think that is a solution, and hopefully we can also figure out how to manage it over an unmanaged network, because I know that's a huge difficulty. I mean, it's relatively straightforward to do it on a managed network because you control everything, but once you get out to the internet, kind of like but I know there are companies out there like Broadpeak and stuff that are trying to figure out how to do that. So all right, let's jump to some questions. We got a lot of questions apparently. Let's start out with looks like some easy ones. So we've got a question that came in around just, are any of you using or considering CMAF? So, I think we kind of answered that, like, depends on the customer, and sounds like, yeah, because some content owners are using CMAF now they're experimenting with CMAF. The next question actually is quite interesting. It's, what's the interest in header compression? Anybody want to take that one? Are so quiet on the topic.
I assume that this is around H2 compressing headers that H11 didn't.
Yes, I was.
Yeah, I mean, we haven't seen too much. A lot of video traffic is not H2. I don't want to surprise everyone, but when we go look at our charts, most video players and all that kind of stuff are still talking 1.1. So until we have a lot more data on H2, which might actually get skipped and go right into H3 with quick, who knows? But I don't think I have enough data right now on header compression specifically from a performance point of view, because we're doing so little of it.
Right. I mean, and that is interesting. And talking a little bit again about quick, I made the joke when Casey mentioned, that what are you using, IETF quick or Google quick? People may not know the distinction out there, that when quick first was developed by Google, they thought this should be available to everybody. Let's make a standard out of it. And they pushed it through the IETF. Well, the IETF's a standards body, moves very slowly. And by that time, Google had been making changes to quick, like improvements that were specific to Google's network. And so you'll hear people in the industry talk about this. This is for everybody out there. You'll hear people say, like, oh, is that IETF quick or Google quick? That's what they're referring to. So you can either adopt a quick that's being standardized by IETF, or you can choose to utilize and adopt quick that's being further developed by Google, but again, is very specific to Google's network architecture and topology. Okay, whoa, lots of questions. Okay, here's the first one. What size HLS chunks do you recommend? Old school was 10 seconds, then it was 6 seconds, some using extremes of 2 to 3 seconds. What is the sweet spot? Who wants to grab that one?
I'll give my 2 cents. All right, so for VOD, I usually see 6 seconds across most of our large customers. Live, you could probably go to 3 seconds in North America. If you're doing global delivery, you have to watch out. The networks aren't like they are in North America and Europe. So assuming it's North America and Europe, go nuts, do 3 seconds live, 6 seconds VOD is what I've seen, but I'll leave it to Marc and Casey to fill in.
Yeah, for live, which constitutes the bulk of what we do, we don't go below 3. But three is a pretty good value overall.
Agree.
3 seconds. Oh, that's fair. I like that. Look, you guys came to consensus.
Yeah, you got a solution right there.
Here's the next question. What are your concerns for data security with peer-to-peer streaming? So something like DRM. Maybe Rob, maybe you can address that a little bit with the StreamRoot acquisition. Oh, you're on mute.
Can you repeat the question?
Yeah. Yeah. So what are your concerns for data security with peer-to-peer streaming, such as like DRM?
So the WebRTC protocol in general, if we're assuming that would be peer-to-peer, you kind of build, it has some built-in security, and then you build on top of that the layers of security that we'd be talking about. When with our StreamRoot product, you're actually just sending regular HLS over the data channel. So it's not using any protocol but HLS. And so there, all the DRM and all the security and everything is already there, and we're just moving packages. It's pretty much digital package delivery at that point. So if you secured it on your origin, it's secured at the player. But in general, I think to answer the overall question, that WebRTC is not as far ahead, or some of the peer-to-peer protocols are probably not as far ahead in the levels of security they get you past audits, for example, as some of the more trending technologies.
Gotcha. Okay. All right. Next question. So this is kind of a long question. Bear with me. It says, in this pandemic, there have been many challenges for producers of content in bringing content from various sources. Right. Fair enough. Yes. What are the strategies for low latency in acquisition before we package it out the door to the CDN or other delivery agent? And then it went on, says SRT versus peer-to-peer calls using UDP, et cetera. Getting the guests in sync with low latency is important first. Anybody want to tackle that one? Casey, maybe?
Yeah, so we've done a lot of remote production. It's actually been kind of crazy the last month and a half in terms of getting dealing with the flood of requests and opportunities coming in, and a lot of these are using a remote production workflow where we will send out, or the agency or whoever our immediate client is will send out a production kit to the remote site, and they'll set it up, and it'll have some cameras and some lights and some simple instructions. And this entails things like pointing a camera remotely and being on a bridge call with somebody and saying, okay, move the camera a little bit to the right and open your iris and things like that. And so if you have to wait 5 seconds or 10 seconds between each step, it actually adds a lot, adds up very quickly in terms of the amount of time it takes to do your production setup. So low latency has been very, very good there. What I will say though is that, when we're doing setup, we'll use very low latency, and we'll use things like WebRTC. And if we're using a contribution protocol like SRT or Zixi, with the tunable latency, we'll set the latency very low during setup. However, when it's time for production, because we are producing things out of, this could be somebody's, home office, or, in the case of a food cooking type show that we've been helping a client with, basically out of their kitchen, we turn the latency back up once everything's set, and we're ready to produce the show itself, and we're not calling camera moves during the show, or if we do, it's very slow, like, okay, get the cookies when they come out of the oven. And so we'll turn the latency back up, because at that point, the end users watching the content at scale don't know how delayed we are. And so it's, we can kind of cheat, and it's more important at that stage to have the extra bit of latency in there to cover any packet loss or network throughput fluctuations. But that's exactly where these technologies have been clutch for us, is in these remote productions. So find things that use Zixi, SRT, and WebRTC for contribution if you're going to do these remote productions. It helps a lot.
Oh, that makes a lot of sense. so we've had this question a couple of times, and we kind of I glossed over it, so I apologize. We need to get this addressed. I'm gonna Mark, I'm gonna point this at you, but it's basically wrist, right? So what are your thoughts on it? Have you guys looked at it? You know, maybe from an SRT perspective, have you looked at wrist? Like, good.
We are part of the video services forum of the working group. In wrist is, if you compare SRT and wrist is taking the standard route. So they took RTP and they said, what can you add to do the next step, basically do the retransmit of the packets. So they added an RFC that allows you to do retransmit of lost packets on top of RTP, which is a wrist simple profile, which does the basic things. It doesn't do any encryption. It doesn't do the timing recovery, but it gives you the packet loss recovery over the link. And they took it to the next level, which is called the main profile, which is a lot more complicated. And again, the same approach, taking RFCs that are already existing out there and put it on top of the protocol. So that's a standards-driven approach. And where we with SRT, we went a very pragmatic implementation-driven approach. Our approach was, we need to solve a problem that we're having, and we fixed it with our ideas and created a custom protocol that is optimized for this use case. And we open source the library so everybody can just grab it and use it. It's same solution with two different approaches.
You know, Rob or Casey, have you guys played with wrist at all? Any anecdotal thoughts?
So we have our Vivix product as part of CenturyLink as well, which is a big contribution juggernaut. But we're always looking at those kinds of protocols, you know, SRT, ZXI, RIST, and so we're kind of going at the pace that the industry is willing to go with us. It's very much customer driven though. If everybody goes to SRT like they have been, we'll be doing that.
All right, that makes sense. Okay, more questions. That one. Eric, throw some more questions at us. and in the meantime, I have another quick question. So it's kind of like an around the horn thing. We'll start with Mark. We'll go to Casey, then we'll go to Rob. But like, you know, where do we think streaming latency is going to be in, let's say, 2 years' time? Right? Better, worse, same. I mean, Eric made the joke when he started this panel that we've had this topic, latency sucks, for like 4 or 5 years, and latency still sucks. What do you think we're going to be in a couple of years? Anything? So, Mark, give us your thoughts.
Well, I think what we tried and played with was a low latency CMIF on one side, if you need the scalability, or SRT end-to-end direct if you just deliver 2,000. I think we see end-to-end latency that can be below a second, might be a little bit, but definitely below 2 seconds. I think that's possible and doable on a reliable scale.
Casey, thoughts?
Yeah, I would definitely agree with that. I think, well, you know, right now we're having a video chat with pretty low latency, so obviously it's not an impossible technical hurdle. I think the scale component of it is sort of the big thing, and I think low latency at scale, 2 years. I don't know. I think really going aggressively below 2 seconds is going to be tough at scale, even in a couple of years' time. We'll see.
No, that's fair.
But I think two is a good target. I think 2 seconds is a very reasonable target.
2 and 2. Rob.
Yeah, I would say looking at least competing with TV latency, let's call it 10 seconds. I think we will have made strides in the next 2 years. I think Apple's low latency HLS will probably at least let everybody get to the next question. Okay, so if we're using this, then how do we use this, and how do we optimize it and all that kind of stuff? There are other solutions out there, and they're really good, but it just seems like nothing's cool till Apple does it. So I think we'll be there. My bigger question, which is way out of for this panel, would be synchronization. I know Amazon bought a company that does low latency and synchronization together, and I wonder, once we see the outputs of that, if that becomes a hotter topic, so that even if we're all 10 seconds behind, you're not cheering while I haven't seen the ball yet.
Yeah, it was Net Insights Psi technology.
Yes, exactly.
Yeah, it's good stuff. It's proprietary. So I think maybe that Amazon is trying to figure out how to make that non-proprietary, which would be really cool. And it's interesting, like, because, you know, we talk about it in a couple of years, you know, my own work with WebRTC, you know, there's a connection max issue, right? There's a scalability issue. Like, how many concurrent WebRTC sessions can you have to a WebRTC server is limited. And so that's a problem, right? Because if you're suddenly talking about, you know, 8 or 10 million people watching the same stream, it's like, I don't have 10,000 WebRTC servers available. So it's, you know, 2 years is going to be an interesting time for us to sort of dig into some of these really big scaling issues of how does this solution work at scale. All right, so some more questions. Let's do a couple more here. I know that we're 5 past the hour, so let's max out here at 15 past the hour. Question here around what may be the issues with latency and content delivery with privacy regulations such as GDPR or HIPAA. So this could include information being lost or delayed in transmit, or wrong information if received out of conversational order, as well as possible flaws that could allow access or misdelivery of private info. I don't know.
So we have network certifications, you know, stuff like HIPAA certified, there's FedRAMP, there's a number of certifications that we could get into. And I think as long as the video, in the event that you need the video to be that private and that secure, and, you know, if it's in Russia, it has to stay in Russia and all that stuff, there are solutions to these. They're not generally used because we haven't run into these privacy kind of issues at mass scale yet. But there are protections that we could use, that there are things that we could do if, for example, if there is HIPAA video that is at that patient level that would be sent out, you know, over a CDN and not user to user, then we just have to make sure it's using the right networks that are certified for that data. It would be no less secure than the actual HIPAA data that is going across the same network. It would just be video. Yeah,
I mean, telemedicine's a peer-to-peer connection. So yeah, I mean, but
yeah.
Interesting question. This is for, let's actually toss this one at Casey. So we did talk about this sort of like, what's the ideal segment size? And so somebody asked the question is, what advantage of 6 over 10 seconds for VOD? Casey, thoughts?
I don't think there is one for VOD. I think for VOD, 10 is fine. You know, latency is not I mean, in my mind, it's not really a consideration for VOD unless you're trying to do some sort of, I guess maybe in like a synchronized viewing experience where, who has those? A couple of different of the big services now where you're going to watch a movie with friends and you want to all watch the same thing at the same time. So group viewing, remote group viewing experiences. Maybe there's a better term for it. I guess it would be easier to synchronize on smaller chunks, but I'm not sure if that would even make a difference. So yeah, if you're trying to tune for VOD, I think 10 seconds is probably as good a value as any other. I mean, with VOD, you really want an uninterrupted experience, and the shorter your chunk size, the more negotiations you're going to have and transactions, HTTP communications with your CDN. So more overhead, basically, if you go to a shorter segment size.
And who just launched the features? Was it HBO Max or Hulu had a viewer watch feature where sort of like you could watch with all your friends at the same time, so it was all synchronized? I can't remember who it was.
Yeah, I want to say it's Hulu. I feel like I saw it on YouTube as well, though. So I know it's a thing that's talked about that somebody thinks people want to do. I'm not sure of the utility of it myself. I don't know. Well, I'm probably the worst person for consumer trends, though.
Yeah, exactly. Yeah, Hulu. Somebody just said Hulu Watch Party. Yeah, so it was Hulu. I mean, it's interesting, right? I'm all for interesting features and technologies around streaming video to sort of see what users want that differentiates it from broadcast television. But anyway, okay, that looks like we're out of questions. We're at the top of the hour, so we're 2:10, which is fantastic. Thanks everybody for sticking around. And thank you to our panelists. So normally you would get a round of applause. So I'll clap for you. Way to go. Yay. I need like an applause thing, but I don't have one. Anyway, really appreciate, Marc, Casey, and Rob for joining us. You guys are fantastic. This really good discussion. There's an endless amount of material that we could talk about. And for everybody out there, again, the SVA will be publishing the best practices for reducing live stream latency probably in a few months. It's going through the final ratification process now. So stay tuned for that. And, then they'll be testing it and publishing more. But until then, we'll all be working together as an industry to figure out how to make latency not suck.